Well, okay, let's get started. Hyping myself up. So, today I'm going to be giving a talk about NoSQL, Firebase, and sort of an introduction to how the two of those work together. My name is Anna. I'm a research software engineer at CCP. And yeah, I think a pretty good place to start with this is to talk about the ways in which NoSQL differs from SQL, which is the more familiar kind of database. So we're going to talk about that as like a quick overview. Um, So databases in general are just a method to store like persistent data over time in an organized fashion that you can like access easily. Relational databases specifically are often like tables of data that have strict schemas that are linked together with kinds of keys and key relations. In this example I give here, we have the idea of like a table of users, which has data associated with the users, like a name or an email, like posts that are made by those users. And then those get combined when somebody does a query to get like, okay, this is a specific post, like a blog post that somebody would make, which gets sent as a JSON file over HTTP, which contains information about both of those things, usually using an SQL join. Nothing super new or fancy there. So if I'm going to talk about why we're using NoSQL, I feel like it's important to talk about what the advantages and disadvantages are for this method. So this is a very traditional, like tried and true method for storing data. It's been around for decades at this point. People have a very good sense of how to use it, a really good sense of like what are best practices. And as a result, there's a lot of really good tooling around it. So we have like very like strong typing in relational databases. We have like very deduplicated data. This is how we're able to have different tables and link them together. It means every piece of information is only stored in one place, and as opposed to having to update it in multiple places, which, as we know, can get like kind of difficult over time. We also really benefit from a very flexible query structure. Like SQL is simple query language, and it allows you to do a lot of very powerful things. Remapping columns, like joining tables, all of that. The other really big thing that SQL does is that it really prioritizes fast writes. So when you have a new piece of information, you want to append it to the database, there's nothing really more that you have to do other than adding a record to a table. That's kind of it. And as a result, if you're trying to get data quickly saved, that's really useful. But by contrast, when you have a relational database, that really strict schema can just as much be a downside as it can be an upside. And in combination with that, when you're doing a whole bunch of joins or mapping different tables together or amalgamating different pieces of information, your reads get really slow. We're talking about like really small orders of magnitude here, but when you have like theoretically a lot of users all trying to access data, those slow reads matter a lot. So like NoSQL specifically, and my understanding comes from the idea of instead of prioritizing the writing of information to a database, let's prioritize the reading of that information from that database. More often users are going to be reading information than they are going to be writing to it, so this makes sense to prioritize. I put a note here, like a good dev experience leads to better maintainability. And this is, I think, one of the really core ideas about NoSQL. The idea that like ultimately we're just storing data in some way, but making sure that us as developers have a better way to interface with that data and how it's being stored means that we're going to have a better time maintaining it into the future. And that's really important for making anything that will last. Do we have any more or any questions before I move on to other stuff? Great. I'll take that as an so NoSQL, the idea here is that we have like a bunch of documents, and those documents are very flexible. Basically, you can imagine them as JSON files, where you have like fields, and then they're mapped to specific values, which are numbers or strings or recursive objects, that kind of thing. And then the idea of the NoSQL database is that you take these like like groups of documents and you group them together in different kinds of ways. Most traditionally is like you have a collection of documents. And these are like, I like to think of them as semantically grouped rather than like type grouped, because there's no strict schema in NoSQL. So even if you have a whole bunch of documents in the same collection, maybe that's a user's collection where you have, like to use our previous example, a first name or a last name or an email, there's no guarantee in a NoSQL like environment that every document in a collection is going to follow that same schema. Another variant on how you can organize data in a NoSQL environment is by graphs. which is really useful for big data sort of inference computation. That's not so much what I'm going to be focusing on here because that's more complicated than I know how to do. But and also is not, I think, what I don't know, our use case is right now. The other really interesting thing to note about NoSQL is that it's newer, and that as a result, it's kind of there's not like a lot of strict best practices in terms of how to organize data and put it together. So you're kind of flying by the seat of your pants. And that was really the impetus for this talk for me in terms of just being able to share some of the information that I know and have learned myself as like guidelines and principles that I use in my work. So really quickly example here. I gave some example sort of like SQL tables. We have like a blog post one. We saw these in the previous slide. And I also reformatted them how they would look as JSON documents. And the idea here, or one of the things that I want to note is like, these look exactly like the HTTP request that we saw in the previous slide. It's the same kind of organization and data structure that allows the server, when you actually request a piece of information, take that document, do no computation on it, and just pass it to the user. And that's going to be a really big theme. When I think about computation in general, I think there's like a broad sort of scale or spectrum you can use, which is prioritizing or like caching information and storing that versus redoing information and like redoing computation and generating that on the fly. A relational database is a lot more about like recomputing values, recomputing information, and a NoSQL database understands that we can store some data. We can have like it's not really expensive to like store an extra field to or an extra document or whatever. And as a result, a lot of like information is cached, and that's a pattern we're going to see going forward. So, any questions on that before I continue to Firebase? Yes, Paul.
So, one big thing in like traditional relational databases is like the concept of a join, where you take tables and you kind of smush them together in all kinds of ways. Is there a parallel concept in NoSQL style database?
Yes, in that there is not one. I'm going to touch on this a little more going forward, but the idea is that you don't want to do any of that kind of information. You want to format your documents, how you're going to use them in whatever kind of service you're making. But I'll touch on that more in a little bit. Yeah. So NoSQL as it relates to Firebase. Firebase is the Google Cloud like cloud-based development tool. It's the backend as a service, and it hosts a NoSQL database and allows you to do like host websites or apps there. It's we use it a lot at CCV, and as a result, it's what I'm familiar with. So that's kind of why I'm talking about it here. I think there's other NoSQL databases out there. MongoDB is the big open source one that I'm familiar with. So a lot of this does apply to MongoDB as well. With Cloud Firestore, which is the NoSQL Firebase implementation, you have documents and collections, and those are organized recursively. So you can have a collection which has a document, and then that document has a sub-collection which has documents, and that document can have a sub-collection, etc. For all of these, when you create an index in Cloud Firestore, it allows for O of n access times, where n is the number of documents retrieved, which I feel like is very useful when you're scaling for a large application, as opposed to a relational database environment where when you're retrieving like data, it is O of n, where n is the number of records, I'm pretty certain, or O of n log n, depending on your index, of course. And the last really big thing to note here before we're really able to continue is like the use of cloud functions as a way to augment your database and how it functions. Cloud functions are, I like to think of them as like a combo of like a database trigger, like you see in SQL or MongoDB, and then like with a little bit of also like backend API worked into it, where it just gives you more functionality and flexibility. And I'll be talking about those more going forward as well. Okay, so just a few principles that I have about how to organize data in NoSQL. So really big thing, and this is Paul getting to your question about joins before. When you are organizing data, it's like prioritize ease of access for that data. You want to like reduce the time for when you get a query to getting the user back their information. So you don't want to have to get a query, pull some documents, do some computation on it, join them together, and then send it back to the user. You just want to have that information ready to go. So in a like a relational database land where we would have like users, which have a list of preferences, which are one to many, you would have this intermediary preferences table, which link foreign keys from users and preferences to get a really complicated join to give you a really weird list. It's a whole thing. In NoSQL land, the best practice would be to take that list of preferences and just store it in the user object, right? They're associated with that user and just keep it there. So this way, when you're going to use that user information, you just have access to that right away. So to your point, to your question earlier, Paul, about like joins, the idea is don't do joins because you already want that information there. If you know that you're going to want users with preference data, you should already do that join ahead of time. And then as users change their joins, just edit that in the document itself, as opposed to removing rows from like a user preferences table. Paul, question.
So I think that one of the reasons in SQL land where they have these like kind of, yeah, sort of narrow tables where it's like you're just one ID links to another ID is to avoid duplication of information, right? Is the implication then that for NoSQL, since we are kind of grouping stuff, that we want to serve it, like there is more duplication?
Yeah, so this is a great question. Paul's asking about duplicated data, which I believe, yeah. Yeah, so you were asking about for same audience, the role of duplicated data. SQL has all of these like intermediary tables to reduce duplicated data. Because we're trying to speed up reads, we don't want to have to do those joins, and therefore we'll just merge those things together. And this is where cloud functions come in as a way to really augment how to do this. When you want to add when you want to update a list of preferences or update something on across the database, a username, an email, whatever, you need a way to make sure that's synchronized across everything. So and that gets really tricky, really hard. So the cloud function, what it allows you to do is like have a bit of computation that will like trigger whenever you, again, like for example, update your name or your email, and then it'll go through the database, find every place where that is referenced, and then just update it like explicitly. So as opposed to having, like, for example, a user ID, which is then attached to a username, so you only update that name once, and then any future query will use that new name. NoSQL would want you to go through that database, update where you use that name so that all those documents reflect that updated information. This, I feel like, rankles for a lot of people who have been using like SQL databases for a long time. I think it's worth it here for a few reasons. One, I think this is not the only thing you can use cloud functions for, and I think that is really worthwhile. But I think two, the other big thing here is that a perfectly designed like SQL or relational database might not have duplicated data, but an imperfectly designed or a real world one probably will. And without the tools to make sure you're without the tools to like acknowledge that the real world is messy and complicated and weird, it gets harder to maintain that over time. So even though like having that duplicated data is risky, I feel like having a system in place to like address that when it happens is still useful. Does that answer your question? Great. And here's the other thing, which I think is very not relational databases. It's like pretty taboo in my understanding. If you have a value that can be computed, not to store it in your database. You like for a lot of reasons, those can get out of phase or out of sync. And then you have incorrect data in your database, which could be generated on the fly anyway. NoSQL wants you to change that because again, we can use cloud functions to keep it up to date. When something relevant changes, we can like reorder that and recompute that value. So we already have it saved. This might be the number of posts, like a last logged in time, something like that. Yeah, just to keep that at the front of our mind. I have a few design patterns that I want to cover too. Oh, actually, I had one more thing here. Yeah, I think the other thing here is like NoSQL is weird. And I think it is really something that should be encouraged to try a thing and then fix it if it breaks, or if it doesn't work, or if it doesn't suit your needs, because the real world is flexible and kind of wishy-washy and like squishy and weird. Trying to design a perfect database is probably not going to work on the first or second or maybe even third iteration. That's going to be something that's like needs to evolve and needs to react over time. And NoSQL really gives you, in my experience, the power to do that, as opposed to having to try and fit a square peg into a round hole. But yeah, I have some design patterns that I would love to cover, but if I have any questions before I move on. Sure. Okay, great. Yeah, so one of the situations that comes up not infrequently is the idea that you have some fields in a database that you want a user to be able to write to and some that you don't. So I might want to be able to let a user update their name, but not their ID, or not their like some kind of like password without some kind of like crypto checking or whatever. The idea for this is to have a collection of read-only documents that the user can view and access, and then a collection of write-only documents that the user can only write to. And then when that write-only document is changed, use a cloud function to update the read-only document. So this allows you to have a really like narrowly defined scope of like, here's the different fields that we have access to, and here's how we can rearrange them to get a user's collection, or a more a more usable piece of data for the kind of application we're building. So this would be your joins, but it would also be when you're trying to protect data, or you're trying to, I don't know, configure everything so that you have it in a way that makes sense, while also being able to have like atomic pieces of information that act as your sources of truth, to reduce amounts of deduplication or duplication. Something I've been thinking about a lot recently is about cloud functions triggering other cloud functions. And this is a genuine problem that you're going to run into. So the idea that like you can cloud functions are these bits of code that trigger on like database operations, a read, or not usually a read, but a write, an update, a create. And as a result, you can have a cloud function that updates a document that triggers another cloud function. And if you don't organize your data right, you're going to go in a cycle. If you have like a post that has a list of users, you could theoretically add a user to that post and then update that post, which means that it has to update the user document and go back and forth and back and forth and back and forth. This is bad. Obviously, infinite loops are bad. So the idea around this is to organize your documents, your collections in your NoSQL database as a tree, and to only update documents, or to only have cloud functions that trigger like up or across that tree as opposed to back down. So the idea here is like, if you have a this like builds on the idea of the write-only collection as well. But if you have like a users, like a write-only user collection, which contains those writable fields, you can have that update your actual visible users document, and then also update all posts that are associated with. That triggers two things. And then your the update to your post collection would then trigger a users collection, which doesn't go back to trigger the post collection. So organizing that in that tree gives you a good sense of, okay, when a cloud function is going to fire, what else is it going to trigger, and how can we make it so that it doesn't circle back and then retrigger itself? Yeah. Yeah, and then something else I was running into a lot recently is the idea that in a NoSQL environment, searching across your like fields in a database is kind of difficult. In a SQL environment, you can like use this like operator, for example, which gives you the ability to search where strings match in some kind of limited regex kind of way. SQL doesn't want you to do that for, again, the sake of those past queries. So what can we do to enable that kind of search functionality without also slowing down our read times? And having a list of the solution that I really come to and really liked recently is having a list of like pre-generated query tokens based on the contents of that document. So if I want to say, okay, I want to search against username and email, you can parse those using your own custom function into a different like a set of tokens. And then when you actually want to query that collection, search against that list of pre-generated tokens. So the example I give here is that we have our base document, which is like we have a username and an email, and those get separated into a whole list of tokens. Then we can actually query for a specific name, which would come up in this list. But yeah, that's everything I have for today. It's still kind of a weird world of NoSQL, and I'm learning as much as I feel like anybody else. But if anybody has any questions, I think that's it. Rob?
I'm curious, just your opinion on, because I deal with this on Honeycomb a lot, where it's storing data in Firebase, and there's like the same exact data repeated pretty constantly.
Mhm.
But I don't necessarily feel like it warrants the time and effort for like work,
Mhm.
just sort of stuff. So I'm curious, like, just what you think of, like, what you found as far as straight up duplicating data and just having it in multiple places versus the really kind of how things are put together.
Yeah, Honeycomb is, I feel like, a specifically interesting use case for me because of the ways in which you're trying to make a platform that is accessible to a lay user. And I don't know, I think that's like a little tricky, right? Because any kind of situation you implement to try and like organize this in a way that's going to make more sense is going to end up leaving other is going to make it's not going to work in all projects. At least that's my understanding. Like honeycomb projects are distinct enough that like managing that is just hard. Um, so in that kind of a situation, I'm not sure there's a great way to go about that. And I think your best solution might be to do some kind of a parsing like after the fact. Like if you know that your data is going to end up having these kinds of duplicated things. I also get the impression with Honeycomb though that you're not going back to update the data that's already in the database. It's mostly like a repository that you'll store information in from various trials and experiments, which I think really gives you a benefit there. The idea of like we don't need to like keep everything super reactive. We just have it afterwards. And then after the fact, when you're doing analysis, like being able to approach that with a script or some kind of like a custom proprietary or not proprietary, but like custom tooling to be able to analyze that data feels like that's where it's gonna like shine best. And in that kind of a context, I still feel like you benefit a little bit from having all the data that you need in its own self-contained blob, as opposed to having to like assemble the data you need from a bunch of disparate places. I don't know if that answers your question.
No, it does.
Okay. Ruthie.
Very basic question, like I don't know experience with databases, but I'm wondering in practice, how easy is it to like for like relational databases to, I don't like Postgres to MongoDB?
Yeah, that's a really good question. So this is about porting like a theoretical Postgres database to MongoDB. I feel like it depends a lot on the kinds of queries you're doing with the data in your Postgres database, is my thought. Worst case scenario, if you're constantly doing a bunch of joins and like a bunch of computation on your actual queries, you're going to end up having a lot of duplicated data and a lot of superfluous collections, I think, which is not great, but like might be doable if like for some reason you need to make that changeover. I think there is value in like a NoSQL approach, but I also don't think that it's going to be a silver bullet that is going to like be the best for everything at the same time. And if you want to be able to really lean into the flexible query structure that a relational database gives you, then I suspect that's going to end up being better for your use case. But at least in my experience doing like web dev specifically, I find that the kinds of queries you want to do are often not that complicated. It's usually a subset of we have all of our data and we're going to like try and get a subset of it, like users by specific thing, documents by like other specific field. And then on that document, you'll have like all the information you need to get it to let it run. But at the same time, like I'm not sure if that's the be all and end all, you know? So yeah. Paul.
So like all the big database vendors like Oracle, Postgres, MySQL, SQL Server.
Yeah.
They implement the SQL standard, right? There's like an ANSI or ISO or whatever. There's like a SQL standard, and they like add stuff on top of that, but they all implement the standard. Is there something parallel in those SQL there?
Not that I know of. Which doesn't mean that that doesn't exist, but it's not something that I'm specifically aware of. My understanding is that NoSQL databases are flexible and broad enough and encompass enough things that having a standard would be kind of difficult. Like in the idea that it's still about taking documents of data and storing them in various ways, but there's not a specific there's not like a unified query language in a way that having a standard would really require. So that's my understanding at least.
Out of curiosity, what's your preference? If you, like, if you're starting a new project and let's say it's kind of greenfield and you can pick, what would you, I guess it's kind of based on requirements, but in terms of preference, what do you?
Yeah, Paul asked, I'm trying to make sure I'm remembering to repeat questions from Zoom, sorry. Paul asked about what my preference would be for a NoSQL versus relational database if I'm starting a new project. I think that depends a lot on like the kind of project I'm doing, kind of like you said, but in general, I think I actually prefer NoSQL. I think it's easier to get off the ground and get like going on a thing. If you're using a NoSQL like database as opposed to trying to I don't know, like to sort of agglomerate like a separate service or do all these things. Like there's a lot more what's the word, boilerplate that I feel like you have to do for a relational database than for a NoSQL database, which if I'm starting a project probably means I don't want to do the boilerplate.
Are there ever like, have you ever seen projects where they actually use both? Or would that just be like a crazy thing?
No, I don't think that would be a crazy thing. When I gave this talk for an ARC meeting a little while ago, and one of the things that was talked about was like, when do you want to prioritize a fast write? And in situations like that where you'll have like a banking application, but that's the archetypal example. You constantly want to be able to have information and like slap it into that database. At the same time, you also want to have a good user-facing application, and those can be separate. So the idea of having a backend service that will query a relational database to get that information, do some computation on it, store it in a like a NoSQL database, and then update that over time, like just automatedly. That might be a really good option to have both. I think that most times you don't need both unless you have a specific use case for one or the other. But that's just my thought. Or you're a really big company or project. Any other questions? Great. Okay, I think we can end it here. Thanks everyone in the chat.